In this video, we will practice right-hand rule with different circumstances and different problems. And this is our Magnetism 3 video. So here are a few questions that we're going to look at. The first one says the conventional current is in the wire as shown in the figure. Copy the wire and sketch the magnetic field that the current generates. So in this case, I have this type of a right-hand rule, and if the current is going away from me, so there is I, current, so here is the direction of the current, it's going away from me, then if I wrap my right hand around this wire, then I'll see that the magnetic field is going to be in this direction. That means if I had the wire in this direction, and if the current was in that direction, then the magnetic field lines will be coming out of the page on the top and into the page on the bottom. And for the next question, number 2, the current is coming straight out of the page. You see that black dot as shown in the figure. Copy the figure and sketch the magnetic field that the current generates. So if the magnetic field is coming out of the page, then I have to again imagine the wire that is coming toward me, and the current is coming out of the page, so here is the current. Then I have to wrap my fingers the way the picture shows, and I will see that the magnetic field lines are going away from me on the top and toward me on the bottom. So the magnetic field lines are going to be in this direction. The next question is the different type of question, a right-hand rule. The figure shows the end view of the electromagnet with the current as shown. What is the direction of the magnetic field? So I see that the current is going to go in this direction. So the current is directed like this, and I have to use this type of hand rule, and my thumb is going to represent the north and the other side is the south, and the direction of the magnetic and the direction of the current, it has to go with the direction of my fingers. So if my fingers are going this way, then the current has to go that way. So the current is going up right here. So that means this is a positive side and this is a negative side. So the current is going down on the back side of the nail and up on the top side of the nail. So I have to show the direction of the magnetic field lines, and the magnetic field lines are coming out of the north and getting into the south. So the magnetic field lines will look like this, out from the north, because I know which side is north, and into the south. So looking at the picture that is given, I have to wrap my fingers around. So that means my fingers have to go wrap, my hand has to be wrapped like this, my fingers. Then my thumb is going to be pointing into the page. So if my thumb is pointing into the page, that means this side closer to me is south, and the side that is farther away from me is north. Then the magnetic field lines are coming out of the north, so they're coming out of the north on the other side, so they're out of the north, and they're getting into the south, so they're getting on this side into. For the next question, we have a current carrying wire is placed between the poles of a magnet as shown in the figure. What is the direction of the force acting on the wire? So what I have is the south pole and the north pole. The magnetic field lines are going to be going from north to south. So these are the magnetic field lines. The current is going away, so the wire is placed like this, and the current is going away from me, so the current is in that direction. So in this case, I have to use the straight hand rule, where the current has to be aligned with your thumb. So I'm talking about this rule. The current has to be aligned with the thumb. The magnetic field lines right hand rule have to be aligned with your fingers, so the magnetic field lines have to be in this direction, and your thumb will show the direction of the current. So this is the current. So the current is going away from you into the page, and the force that is acting on the wire is going to be out of your palm. So try to place your hand where the fingers aligned with the magnetic field lines. Your thumb is pointing into the page, so it's pointing into the page away from you. And then the force acting on the wire is going to be down out of your palm. So here is going to be the force acting on the wire. Sometimes my students say that they like the other version better than the one with a straight hand. So in this case, you have the force is acting as your middle finger, and then B is the magnetic field, the green line, and I is the red line. So you have FBI. So if you place your fingers this way, then the force acting is going to be out of your palm. Magnetic field lines go straight with your fingers, the same as in the other picture, and then the current is aligned with your thumb. Here are two more questions. In number 5, they ask which of the following diagram represents the field of force around a negative point charge. So the negative point charge has electric field lines pointed toward the negative charge, so that's going to be D. And in number 6, the question is, the diagram of magnetic field B is from right to left, as shown below or in the diagram. A proton travels into the end perpendicular to the plane of the page. So you have the magnetic field lines directed in this direction, from right to left. And then you have a proton, a positively charged particle, is traveling into the page, so the velocity is into the page. And they want you to figure out the direction of the magnetic force acting on the proton. I can use either one of these rules. So it is F, B, and I. For the positive charge, it's the same as the current, so you have direction of the current as your thumb. And for the positive charge, this would be also your velocity. So now you have to arrange your hand so that the magnetic field lines are pointing to the left, from right to left. The charge is positive charge into the page, so the velocity or the thumb has to be into the page, and your the middle finger is gonna show the direction of the force acting, or if you use this rule, then the air out of your palm is gonna show the direction of the force acting on the proton. So I hope you aligned your hand and you got an answer as force acting up. So the middle finger is gonna point up, or the palm is gonna be pointing up, and the force acting on the charge is going to be up, so there's going to be the force. Here's another question. You have North Pole, South Pole, and there is a wire in between, so north, south, and the current is coming toward you, and they want to know the force acting on the wire. The magnetic field lines are going to be going from north to south. So I have magnetic field lines from north to south. Now you either use this rule or this rule to figure out the force acting on the wire. So it is flat hand rule. You have again force, F, B, magnetic field, and I, the current. So the current has to be going out of the page when your lines have to be your fingers. So your fingers have to be aligned with direction of the magnetic field from left to right, and the current is out of every page. So in this case, you will see that the force is acting on the wire is again up, so it's going to be up as well. So the force acting on the wire is going to be up. The next question, number 8, it says, which of the electromagnet down in the drawn in the diagram is the south pole? So because your fingers will show the directions of the current, and in this case the current is going up. So you see the current is going up, and so if you align your hand in the direction, or fingers or direction of the current, your thumb is going to be north and this is south. So the answer is going to be the right end. And if they ask you the magnetic field lines, then they will be going out of the north and into the south. In the next question, they have the magnet, and then between the magnet, between the north and south pole, they place the current, and they show the direction of the force acting on the current with the wire with the current. And there is a very good video. If you Google MIT demos for wire in the magnet or magnetic field, you will see this demo, and I have this demo for you in the video lessons, and I'll attach it in the description as well. So in this problem, we have still the same rule, right-hand rule, whichever you prefer the most. So in this case, we have the one side as north, let's say. Well, I do not know which one is north and which one is south. I just know these are the magnets, the poles of the magnet. And then I have the wire. And the current is going away from me in the first case. So in this case, I have the current going away from me. So they show the direction of the current in this direction. And the force is acting up. So they show that the force is acting up. Now they want for you to figure out what direction, which side is north and which one side is south for the magnet. So you have to arrange your fingers where your current is going away from you into the page, and your force is going to be acting up, and then you will know the direction of the magnetic field lines. Or if you use the straight hand rule, again, your current is yellow, you have to align the current into the page, then your force is going to be acting, in this case, let me do it in red. In this case, the force is up, so the palm has to be facing up, and the magnetic field lines are going to be pointed the direction the way they go. So I see that the magnetic field lines are going in this direction for the force to go up. So that means this is north and this is south. So I have the current is going into the page. I have magnetic field lines pointing in the direction of the fingers, and then the force is going to be up. If I place my hand parallel to the ground, so that's what it's going to look like. And when I say up, it's out of my palm. So the top of my hand faces down, and the palm is facing up, and I will get the force acting up. And for the second picture, it's exactly the same. So again, I have two magnets. Now I have the current. Current is coming toward me because I see the current is going in this direction. And the force is acting down. So if I place my fingers pointing from north to south, then I will get the force. My palm has to be facing down. So my palm is facing down, my thumb is pointing at me, and my fingers are from right to left, and I will get the force acting down. So I know that the right side is north and the left side is south. In this question, they ask you to determine the direction of the current if the polarity of the electromagnet is given. So they tell you which one is north and which one is south. So I see I have north side on this side and south on the other side. That means if I wrap my fingers around, my thumb shows north, and the current is in a direction the way I wrap my fingers. So that means the fingers must be showing the current in this direction. So if the current is in this direction, then that side must be positive and this side must be negative, because the current is coming in this direction from positive to negative. So they ask you to show the current and polarity. So for the polarity, I have positive side, negative side. And for the next question, they tell you this is positive side. So the current is going in this direction. So the current is going to go up like this. And this is the negative side, for the charge or for the battery. Then that means if I wrap again my fingers the way it's shown in the picture, I will have this one is north and this one is south. So you see different types of right hand rule is used for different cases. So here when you have a coil, you have to wrap your fingers for this case. And when you have a charge or the wire in a foreign magnetic field, then you have to use that right hand rule or FBI rule to figure out the direction of the current, magnetic field, or the force acting on the wire or the charge. So here in this question, we have to determine the direction of the force on electron in the magnetic field. And in this case, we have the magnetic field coming at you. So the magnetic field lines, you see the dots. So the magnetic field lines are like this. And the electron, the negative charge, is flying in this direction. So it is again this rule where we have straight hand rule or FBI rule, whichever you prefer to use. I like my straight hand rule. So the current is also the direction of the charge, so that is the velocity. So my thumb has to be pointing to the right, my fingers have to be pointed toward me, and the force on the positive charge and on the wire with the current would be down, but on the negative charge it's in the opposite direction, so the force in this case would be up. In this question, they say the direction of the force on the wire that you need to find, and they give you the current. So the current is to the right. The current is to the right, and the magnetic field line is into the page. So the magnetic field lines are into the page. And I have the wire with the current. And the current is pointing to the right. So it's the same right hand rule when you place the wire into the foreign magnetic field lines. So these are the magnetic field lines. And I have to point my fingers away from me, the direction of the magnetic field lines. I have to point my thumb to the right, and the force acting on the wire is gonna be up. So the force acting on the wire is up. In this question, they made their own coil, and in this coil, the current is flowing from positive charge to the negative. So you have the current is going in this direction on the top or in front of the coil, and in that direction. So I can use the curl rule for the coil. So if I curl my fingers around the coil, I will end up with my thumb pointing this way. So this will be north and this will be south. And you cannot relate your north and south to the polarity of the battery. It always will be in what direction the current goes and in what direction the thumb points. So the thumb is always going to be the north side. For the next question, they say determine whether the two solenoids will or coils will attract or repel. So for the one on the right, if I use this rule, then I will see that this is north and this is south. And if I use on the one on the left, I also see this is north and this is south. So I'm using this rule shown in the picture where the fingers are aligned with the direction of the current and thumb shows me which one is north and which one is south. So these two will repel. In the next few questions, they ask you to indicate the direction of the force on the current carrying the wire in pictures below. So you have the current. So here is the current. The magnetic field lines point to the right. So if you use this rule, one of those, it doesn't matter which one you like the most, then you will see that if the wire is pointing up, the current is pointing up, and the magnetic field lines to the right, then the force is gonna be into the page. So this is into the page. Force is into the page. For the next one, the wire is parallel to the magnetic field lines, so the force is equal to 0. There's no force action when the wire is not under an angle with the magnetic field lines. For the next one, your magnetic field lines are pointing down, so the magnetic field lines are pointing down, and the current is out of the page. So if the current is out of the page and the magnetic field lines pointing down, then I have force acting to the right. And if you need more time to figure out how to use each hand for each problem, pause it and try to solve it on your own before you see the answer. For the next question, the magnetic field lines are to the right and the current is away from you into the page. So if I point my fingers to the right hand rule, so right hand fingers to the right, and then I turn my page parallel to the ground where my palm is facing down, then the force is going to be out of the palm facing down. And the current, the thumb, is pointing toward the page. For the next one, you see that the magnetic field lines are into the page, but the current is out of the page because you see that the dot in the middle. So because they are parallel, there's going to be no force acting in this case. So force is equal to 0. For the next problem, we see the magnetic field lines coming out of the page when the current is going to the left. So now you have to figure out the direction of the hand so that the magnetic field lines pointing toward you, fingers are pointing toward you, and the thumb is pointing to the left. I know it's a little bit uncomfortable position for your right hand, but if you do it this way, then the force is going to be acting up. So the force in this case is up because your hand is again parallel to the ground. Palm is facing up, fingers toward you, thumb to the left, and because palm is facing up, the force is acting out of the palm. And for the next question, you have the magnetic field lines to the left. The current is away from you. That cross means the current is away from you. So now you have to face your fingers to the left when your thumb is pointing toward the page, and again the force is gonna be up. In this question, what they tell you is you have a positive charge which is not bubble in, and a negative charge that is dark or bubble in. So, and the magnetic field lines are shown as well. So in the first problem, and it's the same rule. In the first problem, I have the magnetic field line and the positive charge is moving up. So my right hand is gonna be, so it's gonna look like this. I have the right hand pointing like this, with the velocity is in this direction, the magnetic field lines in this direction, and the thumb is pointing away from me. So that means the force is gonna be into the page for the positive charge. For the next question, I have the negative charge is moving to the left, negative charge is moving to the left. The magnetic field lines away from me. So now my hand is going to be parallel to the ground with fingers pointing away from me, and the thumb is pointing to the left, and my palm is facing down. But because it's a negative charge, the force is not out of the palm, it's in the opposite direction. So the force acting on this case is going to be on this negative charge is going to be up. For the next question, I have the magnetic field lines down. The negative charge is moving to the right. Then I have my thumb pointing to the right and my fingers pointing down. Because it's a negative charge, the force is going to be out of the page, and in other words, it's toward me. For the next question, I have a positive charge moving to the left. The magnetic field lines away from me. So I have to point my fingers away from me and my thumb to the left, because the positive charge is moving to the left. And then the force acting on this positive charge is going to be down. For the next question, I have the magnetic field lines up, so my fingers are pointing up. The charge is moving to the right, so my thumb is pointing to the right, and so that looks like I'm looking at my palm in front of me, and the force is acting out of the palm. So if the force is acting out of the palm, then the force is out of the page. So the force is out of the page in this case. And for the next one, they're parallel, the magnetic field lines and the negative charge, so they're not under an angle, so that force is equal to 0. Next question, you have the magnetic field lines coming toward you, so your fingers pointing toward you. The charge is moving to the left, so your thumb is pointing to the left, so that looks like your palm is going to be facing up, and it's a positive charge, so your force is up in this case. So your fingers point toward you, your thumb points toward the left, and your palm is facing up, so you have force is acting up. And for the next question, we have the magnetic field lines pointing toward me, so the fingers are pointing toward me. The thumb is pointing up, so the thumb is going to be pointing up. So the fingers are toward me, the thumb is pointing up, so that means your palm is gonna be pointing toward the right, and if your palm is toward the right, then the force is to the right. Oh, it's a negative charge, so the force is not to the right, it's in the opposite direction. So for the negative charge, it's toward the left, so your force is toward the left, because your palm is facing to the right, but your the force is going to be acting in the opposite direction to the left for the negative charge. And I will stop here for now for our right hand rule practices, so that we didn't have to do any calculations, but a lot of right hand rule problems solved in this video. And I will say thank you for watching this video, and follow the links in the description, and I will see you in the next video.